Hey everyone, you're watching the Space Channel. Why doesn't the moon fall to Earth? Why don't all the planets in the solar system fall into the sun? People ask us this a lot, and while we've covered it in previous videos, let's take a closer look. If you recall the law of universal gravitation, it's easy to calculate the gravitational force between Earth and the moon. That constant gravitational pull on the moon should give it an acceleration toward Earth. So, following that logic, the moon ought to move toward Earth and eventually crash into it. That's probably what the questioner had in mind. And that's precisely what would happen if the moon were stationary relative to Earth. However, in reality, the moon is orbiting Earth at a very high speed. That's why it doesn't fall to Earth. But what is an orbit anyway? Let's go back to a thought experiment first proposed by Sir Isaac Newton. Imagine a cannon mounted on a mountain that can fire cannonballs horizontally relative to the planet's surface. The projectile's velocity is parallel to Earth's surface and perpendicular to the direction of gravity. At every moment, the cannonball tries to move straight ahead, but gravity continually bends its velocity vector downward toward Earth. As a result, after traveling some distance, the projectile falls to the ground. It's easy to notice. The higher the initial speed, the farther it flies. Now imagine our cannon can fire at any speed we want, and we gradually increase the launch speed. Soon, the range grows not only because of the higher initial speed, but also because of Earth's curvature. The cannonballs start disappearing over the horizon. In other words, the surface of Earth seems to drop away beneath the projectile. You can choose a speed at which Earth's gravity pulls the cannonball downward by precisely the same amount that Earth's surface curves away beneath it. A projectile moving at that speed would keep circling Earth forever, ignoring air resistance. The speed you need to give it so it stays on that circular path is called the first cosmic velocity, the circular orbital speed. Near Earth's surface, this speed is 7.91 kilometers per second, but it decreases with altitude. At the moon's average orbital distance, it's about 1.022 kilometers per second. And believe it or not, that's essentially the speed at which the moon moves along its orbit. That's why the moon doesn't fall to Earth. It tries to move in a straight line, but Earth's gravity keeps slightly deflecting it, so it ends up orbiting Earth. People sometimes say the moon is falling toward Earth but constantly missing, and that's basically true. The same principle applies to the planets in the solar system, which is why they don't fall into the sun. That's all for now. Subscribe to our channel and leave a like if you enjoyed this video. See you next time.